In this video, we're going to go through the same process that we did with the Fibonacci solver, except we're going to use memoization to significantly reduce the number of recursive calls. Now in this slide, I say a hash map, and I'm doing this deliberately in order to preview what we're going to go over in lecture 7. In the solution I've presented to you in the reading, I use standard vector as a kind of default hash map. What this means is I have certain buckets. So when I passed fib5, I created 5 plus 1 buckets. And what's going to happen is you're going to see that when I say fib0 or fib1, that I am going to store the previously derived solution to the problem. So let's go through the trace and see what happens. So when I go through fib5, just like before, I split to fib4 and fib3. And then I make the left call first. I have fib3 and fib2 set up. Same thing as before, I have fib2 and fib1. And then I get to fib1 and fib0. We now have 2 base cases. So when we get to fib0, I'm going to store the result as 1. And then I do the same thing with fib0, and now I have the previous result stored. So when I go up to fib2, I return that, and I store that result in the standard vector as well. When I make the right call, what we've done in the code is instead of saying, all right, I got to check the base case, I just check to see if a value is in the vector. We see that it's there, and I automatically do the solution. We add 2 and 1, and we store that result in 3. Now I would want to make the recursive call to 2. Before, I had to go to fib1 and then fib0. I don't need to do that anymore because I actually have the result of 2 saved. And now we can return that as 5. And then in the previous video, we spent a lot of time going over this because this would be fib2 plus fib1, and we have to do all this work below. We don't need to do that anymore because we have the result of fib3. So now we return the result, and now we have 8. And here's the comparison I also present in the reading of a significant reduction between the recursive calls without memoization and the recursive calls with memoization. The recursive calls with memoization becomes 2n minus 1. So instead of doing 1.4066 times 2 to the 209, I'm only doing 1,999 calls. So let's compare the results. When I run make fib, it compiles, I did 1,000, and I told you in the previous video that this takes a long time. Running the same code that I presented before, and if I run fib memo with 1,000, we're going to see that I get the solution almost instantaneously. This is the benefit of understanding recursion and being able to store previous results to significantly improve how the data flows through the computing device.